Hi, my name is Cedric. Let's talk a bit about spalling, the structural concern for home inspectors. The formation of efflorescence relies on three essential elements. 1. Soluble salts present within the building material. 2. Moisture to dissolve and transport these salts. 3. Evaporation that concentrates the dissolved salts at the surface. Concrete, brick, stone, and mortar naturally contain mineral salts, as do the soils surrounding foundations. When these materials absorb water through capillary action, a process where moisture moves through the porous structure due to surface tension, the water draws salt with it. This capillary pressure, though relatively modest at 300 to 500 psi, is sufficient to facilitate significant moisture movement through building materials. While efflorescence serves as an early warning, spalling represents a more advanced deterioration process, where the surface material actually breaks away from the main body of concrete or masonry. This flaking or fragmenting occurs when hydrostatic pressure builds within the material to levels exceeding its tensile strength, typically between 3,000 to 5,000 psi, causing portions of the surface to detach or blow off. Spalling frequently develops through two primary mechanisms. First, hydrostatic pressure. As more salt accumulates beneath the surface, the osmosis process draws increasing amounts of water through the material. This osmotic action generates substantial hydrostatic pressure, potentially reaching 3,000 to 5,000 psi. With concrete typically having a structural strength of 2,000 to 3,000 psi, this pressure can overwhelm the material's capacity, resulting in surface failure. Second, freeze-thaw cycles. In colder climates, moisture trapped within porous building materials expands upon freezing. Repeated freeze-thaw cycles progressively weaken the material's structural integrity. Materials with higher moisture content are particularly vulnerable to this cyclic damage. You may be interested in learning more about soils that heave under foundations in a recent inspection training article titled Frost Heave Caused by Ice Lenses, available from our tuition-free home inspector college at InterNACHI.org. When evaluating spalling, inspectors should document depth and extent of material loss, whether reinforcing steel has been exposed, presence of concurrent moisture issues, location patterns that might indicate systemic problems, and finally, structural implications based on the affected components. A critical function of the home inspection process involves educating clients about maintenance strategies to prevent moisture-related deterioration. Effective prevention typically focuses on interrupting the moisture pathway through capillary breaks, installation of subslab polyethylene sheeting or liquid-applied elastomeric waterproofing creates a barrier to moisture migration. Drainage improvements, proper grading, functional gutters, and effective downspout extensions direct water away from the foundation. Masonry maintenance. For existing masonry structures, repointing of mortar joints can help maintain the integrity of the assembly. Sacrificial mortar. In some masonry systems, mortar is intentionally formulated to be softer than the surrounding masonry, allowing it to degrade preferentially and protect the more valuable structural components. Vapor retarders. Proper installation of vapor retarders in crawl spaces and basement areas can reduce moisture movement through concrete. Learn how to inspect vapor diffusion retarders by visiting InterNACHI.org/vapor retarder inspection. Sealants. While sealants alone aren't a complete solution, hydrophobic impregnating sealers can help prevent water intrusion in some applications. Dehumidification. In enclosed spaces with existing efflorescence, dehumidification can slow the process by reducing ambient moisture, though it won't address the underlying cause. The capillary potential of concrete is extraordinary. According to the Building Science Corporation, while the theoretical limit of capillary rise in wood is approximately 400 feet, concrete's capillary action can theoretically extend nearly 6 miles. This remarkable characteristic underscores concrete's vulnerability to moisture transport and explains why seemingly minor groundwater issues can affect areas far from the apparent moisture source. Efflorescence and spalling represent more than mere surface phenomena. They serve as diagnostic indicators of moisture management within a building's envelope. By understanding the physical processes involved in moisture management, capillary action, osmosis, efflorescence, and spalling, home inspectors can provide valuable information that goes beyond simple observations. Identifying observed indications of moisture intrusion early can help homeowners keep their homes in good shape and demonstrate the preventative maintenance value that home inspections provide. The remarkable capacity of concrete and masonry to transport moisture through capillary action underscores why these conditions deserve particular attention during foundation inspections. By integrating an understanding of building science, code requirements, common building practices, and professional inspection standards, certified home inspectors position themselves as invaluable resources in the preservation and maintenance of residential structures worldwide. Thank you for listening. Stay safe out there.